packet pushers.
Welcome to Day 2 DevOps, where the DevOps is in the details. I'm Ned Bellavance, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on day 1 and beyond. With me on this journey of learning and doing is my co-host, Kyler Middleton. Hi, Kyler.
Hi, Ned.
Today is a sponsored episode with Cisco ThousandEyes, where we will be exploring their newly updated Cloud Insights product with Prab Singh, Director of Product Management, and Nelson Rodrigues, Senior Director Engineering of Cisco ThousandEyes.
We talked about some incredibly compelling stuff today, like peeking into the black box of your cloud networking to see what actually is going on and where your pinch points are in these very complicated cloud networks. And how ThousandEyes can act like a DVR for your network to look back and see that actually that network drop happened because of a configuration event in one of your services in the stack. Or looking forward into the future to see what might happen based on a proposed change to predict what'll happen into the future.
Well, let's get into it. With no further ado, here's Prab and Nelson. Well, welcome to the show, Prab and Nelson. We're excited to speak with both of you. Prab, let's start with some basics. For those who are unfamiliar with ThousandEyes, give us the elevator pitch.
Thanks for having me, Ned and Kyler. I'm Prab, and I lead some of our core products here at ThousandEyes. And yeah, ThousandEyes was born out of internet research, really around visualizing and understanding impact of large-scale networks like DNS systems and also internet as a large-scale network and how they impact businesses. I think we all have lived in an internet-only world for as long as we can remember, but internet really wasn't a big thing for businesses until about 15 years ago. Believe it or not, cloud computing really only took off about, end of 2010s when Azure came out, EC2, like the late 2006 to 2007s. And then that essentially gave rise to internet as a medium to connect to applications that were in the cloud and the SaaS. And so ThousandEyes was born during this transition, and we've built our core capabilities around helping you see external networks and how they impact applications for your users.
I think it's wild that during the beginning of the pandemic, there was this big push for digital transformation. And it turned out there were a lot of businesses that were still not online, which I thought was just wild. Mm-hmm. Speaking of businesses, what are the business challenges that ThousandEyes is trying to solve? And has that changed over time?
I think somewhat have changed, and you mentioned the pandemic just now and how that's shifted trends and what we see. And I'll maybe give you a quick brief history lesson how we've seen this over the last 15 years or so.
Yeah.
I briefly alluded, I think the emergence of cloud computing really meant that businesses that operated on-prem software for their business functions, could be CRM, could be, system of record for employees, realize the benefits of using cloud computing, whether that's migrating their applications to clouds so they can be faster, they can use the scalability platforms of cloud to be able to deploy those applications, or just turn those applications off altogether in data centers and purchase a SaaS subscription that allows them to, continue to be productive as a business. That obviously put a ton of pressure on connectivity because connectivity that originated from an office in a cubicle across that network getting to a data center has now changed because now internet is really sort of your medium to connect to these applications, either in the cloud that you're migrating and lifting and shifting, or SaaS as an application. And that's basically what gave rise to SD-WAN. Believe it or not, up until 10 years ago, SD-WAN was not a thing. It was really just a WAN, wide area network that connects applications and users. And software-defined networking and software-defined WAN specifically was around how do we leverage the power of the internet to be able to connect you to applications at scale across many locations. And then as that's changed over time, I think pandemic changed that, where SD-WAN or software-defined WAN morphed into Secure Access Service Edge. SASE is the acronym that we all use around that. Yeah. And that's really not just about connectivity and networking and connecting applications to users. It's also how do you secure them? And that became a really massive thing through the pandemic in the last few years that we lived through, because we all started to work from home and we needed to secure users, whether they were coming from the office or coming from home, the same way and provide the same level of experience to those applications applications. And that's basically what gave rise to a lot of we call the middle mile providers that we see with the likes of Cisco Secure Access, Zscaler, Palo Alto Prisma, et cetera, Netscope, and others in the industry that are providing you connectivity and security to applications either in the cloud or on-premise.
So I was involved in a lot of email and Office 365 migrations when I was in consulting. And so this really resonates with me because one of the things we had to check before we went through the migration was, what does your internet pipe look like? Because a lot of the organizations I worked with had a very robust internal WAN to connect all their sites. But then all of the internet bound traffic would be ported back to their central data center and going out a single pipe there. And when they started adopting Office 365, that became a real bottleneck for all of the remote offices and the main office because suddenly they're getting smacked with all this traffic that they did not plan for. So what you're talking about, I felt that.
Yeah, you talk about capacity, bandwidth being a concern. That became a big concern in the pandemic for VPN concentrators.
Oh, yeah.
Imagine everybody, tens of thousands of employees logging into a VPN provider and realizing my VPNs can't scale and I need to purchase more capacity on my head-end locations. And then also what we realized is while the internet gave you flexibility and maybe even lower costs across your wide area networks, it also brought complexity because at the end of the day, internet is unreliable or it can be unreliable. And unless you have ways to have redundancies built in, you have multiple providers, and be able to see how internet is impacting user experience became sort of a complexity that arose with the benefits that we saw of this migration. And so that's partly what we've been focused on is how do we bring clarity to this complex world that we see across, these various systems that are part of what we call the digital supply chain from the end user to the application and everything in between.
Not only I would add to that like Ned was pointing out, before an enterprise would own all of the networks that their traffic would pass through, right? Like you were saying, they would own the data center, they would own the branches, they would completely own the WAN end to end for how those branches connected to those data centers and to those applications. But with this move to SD-WAN and the internet as the backbone, these enterprises don't own the internet, right? So they don't own the end-to-end experience, but they still own the end-to-end outcome, right? So those teams are still responsible for and are still accountable for how Office 365 is delivered and the experience of accessing Office 365.
Absolutely. And cloud has changed the game even more, right? You own your network even less than before now because these IPs come and go and resources come and go and they're apportioned to just someone else's network, what cloud really is. But I want to talk first about this. So since ThousandEyes is a SaaS product, is it safe to assume that you're using ThousandEyes to monitor yourself? And if so, how has that informed the evolution of your feature set?
So in the early days, we had our own data centers. So we are a SaaS subscription that customers purchase. There is no on-prem solution. And so our software stack was built in our own data centers. And one of the reasons we actually chose early on not to deploy in public cloud providers was because our customers were moving to the cloud. They were using SaaS services that tended to be built on other public cloud providers. And as a monitoring system, as an intelligence system, we didn't want to have the same dependencies as our customers. When they are having an issue, we need to be up and we need to make sure we don't have the same dependencies. Obviously, that changed over time. Most of the hyperscalers now have multiple regions around the globe. We have systems in place, best practices in place, and how do you build across cloud providers while maintaining high level of redundancies and failure scenarios that allow you to continue to be up for your customers even when they're having an issue. And so we did our own cloud migration like our customers did starting about 6 years ago. And interestingly enough, we looked at multiple cloud providers, we partnered with AWS, and so we started migrating essentially our own application, which was at that time maybe a monolithic application in our own data centers, and we migrated to the cloud. That obviously takes a long time. It's not something that happens overnight. Most customers will take a long time and may even stay between cloud provider and an on-prem environment in a hybrid situation. For us, we realized we needed to move to the cloud as quickly as possible, partly because we were acquired by Cisco in the middle of the pandemic in 2020. And so we just saw a tremendous interest across the Cisco customer base. And so we needed to really almost accelerate our cloud migration so we can serve more customers faster.
Sure.
And so as of 2 years ago, we have no more data centers. Our application is deployed across multiple regions of AWS using microservices, using cloud native services like AWS Global Accelerator that allow us to serve our customers globally while reducing time to first byte using TCP optimizers and AWS Backbone to get to our applications. So that's a bit of our journey, and we've kind of been on the same journey as our customers over time. And as we've done that over the years, we've always used ThousandEyes on ThousandEyes. So we have our internal dashboard that we've built for every internet-facing service that our customers utilize. And from an operational standpoint, we measure its uptime, and there's alerts and notifications built in that give our on-call engineers a proactive notification when we see any minor degradation, so we can respond to that and make sure we continue to increase uptime of our services over time.
We're also big users of ThousandEyes when evaluating the locations where we are deploying cloud agents. Every single cloud agent is deployed in a partner location in the data center all around the world. And we want to make sure that those locations have great connections to the internet so that when we're diagnosing issues, we are diagnosing issues on the internet and on the service that is being monitored. And we're not looking at an issue caused by the vantage point itself. We're actually using ThousandEyes to make sure that the locations that we deploy these cloud agents have a very healthy baseline of network connectivity.
What does the cloud agent do? Because I've heard the term used before, but I'm not exactly clear on how it integrates with the rest of ThousandEyes and helps inform what you can see in the dashboard.
On a basic level, what ThousandEyes is we have agents. Think of them as probes, but they collect test data, and we call them tests, and we do measurements against servers or IPs or destinations you instruct them to go collect data to. And that data gets collected from these agents. These agents can either be deployed on-premise, so they can be deployed on Cisco switches, Cisco routers, as a Docker container within your own data center, as a VM using virtual appliance. Or these agents can be cloud agents, like Nelson was alluding to, which is these are agents that we provide you as a service across all parts of the globe, across hundreds of locations around the world. And so cloud agents serve as sort of an internet vantage point to measure experience and health for your internet applications. And enterprise agents serve as vantage points for applications either that could be internally available or even SaaS applications that you're trying to reach from within your four walls.
This is blowing my mind because I cannot count the number of hours I have spent writing TCL to put on like Nexus switches, doing IPSLA statements to like ping stuff and then try to gather that data with like a SolarWinds or something. It sounds like I could have just used this product, and that sounds wonderful. Like the number of hours I would have saved.
It's definitely one of the use cases we see from our customers, and they sometimes call us like IPSLA on steroids, if you were to look at ThousandEyes that way.
I guess those agents are the ThousandEyes. Wow, it all came together there.
I just got that too. Mm-hmm.
So you're really in the business of monitoring what's happening on the internet and what's happening inside these enterprise environments. But cloud's a whole different beast. And I'm sure you discovered that as part of your migration. The cloud providers give you a certain amount of visibility. Their networks don't exactly follow the same structure or the same format, and you don't have access to like the bare metal of those networks. So what did you discover as you were trying to instrument for your own applications and for others for the public cloud?
As you move to the cloud providers, one, as we've always been using ThousandEyes on ThousandEyes, we realized, one, we do need to ensure that we have as much of the end-to-end as possible to help understand the experience. And in order to do that, we realized we needed to have newer data sets and new techniques to understand cloud infrastructure and performance that is somewhat different than how we've seen the internet and on-prem environments. The same techniques that we use to essentially, for example, find a path visualization across the internet and on-prem that essentially is an IP address-based view of hop by hop how traffic is going from point A to point B, it becomes less relevant in the cloud. Because in the cloud, as we deploy microservices, we deploy ephemeral services that go in and out based on the needs of the application, IPs also go in and out. So tracking IP addresses make less sense. What makes more sense is understanding the service and how it's configured within the cloud and stitching it together with the internet, with the on-prem, with the private connectivity views that you have, so you can see as much of the digital experience as possible. And so what we did specifically with the cloud, and recently what we've developed, is a new product, and it's called Cloud Insights. And what it does is effectively go all the way to the front door of the AWS endpoint, so our application stack. And typically, an ingress point to AWS from the internet or on-prem it could be an AWS Global Accelerator. It could be a load balancer behind an internet gateway. It could be a direct connect gateway if you're going across a private network. It could just even be an EC2 instance that, is in a public subnet and you've got access to that over the internet. In most of those scenarios, once you get to the AWS front door, the cloud provider in general, and this applies not just to AWS, but also to Azure and GCP and other cloud providers, but they effectively become black boxes. And what we did with Cloud Insights was we pulled together a set of information that allows us to build a PathViz-like capability, essentially a topology of your service that you're measuring with some of the agents that we have. So we can tie together performance and performance degradation availability with cloud provider infrastructure and changes you're seeing so we can better understand the health of that service.
Okay. So I think it would be useful to walk through an example, but if I could sort of summarize what I'm hearing, you're leveraging the APIs of the AWS to see what's actually going on inside of a given VPC or something like that. Are you also collecting things like VPC flow logs or something like that to get more information about what's happening inside that network?
Yeah, one of the most interesting sets of insights that we gained when we were discussing how to build this and like what techniques to be used was one, typically when there's a problem impacting an application and a set of users, there's maybe two different types of issues that can happen. First, there could be sort of a configuration change relating to a software upgrade or a scheduled maintenance that causes an issue, or it could be an infrastructure-based issue where it's an underlying AWS issue that's causing a performance degradation or an availability problem with the application you have in the cloud provider itself. And when we were discussing this, we realized we needed to build the solution where we can also not just measure the topology and performance, but also correlate it with changes that are happening across the infrastructure. And so these changes are actually more frequently the cause of heartburn for these applications, because as we've seen a lot of the times, most of the time when there's an issue, it's because somebody pushed a button somewhere, whether that's a manual button or an automated button. And if we can help you figure out who pushed what button at what time and correlate it with the performance measurements we're doing, that was really the core capability we introduced within sort of Cloud Insights that goes above and beyond what we've traditionally seen.
That sounds so powerful. I mean, every network engineer listening, like a lot of our audience is network engineers, knows that finger point when something breaks on the application and they point and they say, it's the network. And you say, it's not the network. And they say, prove it. You are guilty until proven innocent. And the complexity of cloud networks to prove that it is not the network is so challenging. If you're using CloudFront integrated with WAFs that have a cache that point at an origin, a load balancer that points at target groups, that points at hosts, and it could be any of the hosts with the issue, the ability for humans to manage that kind of complexity and troubleshooting is huge. And I think tools are just flatly required at that point for you to actually know what's going on.
And it's an ever-changing environment too, where the state of the application and the services are deployed changes over time. So how do you play this like a movie and have the historical context of what changed at what time is a really key part of this. And so being able to see changes in historical context is also a really important point.
I was just going to say that it's not just the complexity and the change, but the rate of change has increased a lot over time, right? Mm-hmm. As an industry, when we introduce capabilities like infrastructure as code and GitOps and best practices around all of this, we've empowered application teams to produce change at a higher rate and to get those changes in front of customers very quickly, right? So for network teams and infrastructure teams to understand how their architecture is evolving over time, it is very, very difficult just because the rate of change has increased a lot as well.
And I'm just realizing that we've talked about like on-prem versus cloud, but a lot of enterprises are now multi-cloud. And so you're not just managing all the complexity of one network stack, you're managing all the complexity of several different cloud stacks with their different technologies and abstractions and, troubleshooting methodologies. That sounds so difficult. So does this tool permit you to see and troubleshoot flows that sort of cross cloud boundaries? Is that something we can do here?
Yeah. So Cloud Insights is cloud agnostic. One of the things we want to do is help any organization, whether they're using one of the major 3 cloud providers or even others, to be able to see it using the same single pane of glass, if you will. So being able to see the on-prem, the internet, and any cloud provider together is really key part of that. Because as we've seen when we talk to customers, is almost every organization, at least large organization that we talk to, has at least two cloud providers, if not more, that's prevalent across their orgs. We haven't yet seen, the single application deployed across cloud providers, but it's different distinct teams deployed across multiple cloud providers. And as a platform engineering team or an IT operations team, I need to have a single solution that can help me see across cloud providers and then tie that with my on-prem and internet views as well. And that's why we've been focused on building this across cloud providers, starting with AWS. We'll do the same thing with Azure and GCP as well, and others.
Now, yesterday during our briefing, you showed us a demonstration of ThousandEyes in action, and it was pretty cool. I'm not going to lie. And part of what was really cool is the fact that it had a visual component where you could sort of browse through things. One of the challenges to having a really low mean time to resolution is being able to determine what's causing this problem. And as much as I love combing through logs, we're visual creatures by nature, and we prefer a visual interface for kind of seeing what's going on. Can you just sort of describe the interface a little bit and what someone can do with it if they're trying to just triage a problem?
Yeah. On the basics, the way we've built Cloud Insights is we've created a new integration with AWS, and we'll do the same with other cloud providers, where you create an identity access management role, an IAM role, where with the correct trust and permission policies giving us access so we can essentially build an inventory of your cloud infrastructure. Once we build an inventory of your cloud infrastructure, the key value is how do we then tie that to how specific parts of your infrastructure are serving a particular application when you go from point A to point B. So for example, imagine you have an application that's deployed in the cloud provider. You've got a component of that application stack that's on premise, and you want to be able to make sure that the connectivity between the two is always present, and there's any changes you want to be alerted as quickly as possible. In that scenario, what you would actually do is you deploy an enterprise agent within your data center. Again, this could be a Cisco device, a Docker container, virtual appliance. You would point it to a service that's deployed in the cloud. This could be a host name, the service itself, an IP address. And what we do specifically is we measure the availability of that application. We measure its response time, which is like time to first byte, which is a good initial indicator of performance. We measure loss, latency. We build a path visualization or by hop. And then within the Cloud Insights tab, we've created a new layer that's deeply integrated within our end-to-end views that then crawls over and finds the inventory within AWS that is serving the infrastructure that's serving that application once we get into the AWS. So in the case of a private connectivity in our data center, that's typically, a direct connect gateway with its virtual interfaces that connect to a transit gateway typically, because transit gateways, you're a conduit to different VPCs. Once you get to a VPC, you're then connecting to particular EC2 instances. So imagine that entire end-to-end put together in a visual format where you can go from on-prem to the direct connect through the to cloud environment all in one view.
Right. And you can zoom in. That's what you were showing us, is you were zooming into the application and showing us, here's the target group and here's the EC2 instances behind that. And then like being able to forward and rewind on time, you showed us how, okay, and here's where there was a drain event and nodes were leaving the load balancer and then they were coming back. And that caused a blip in connectivity. And you can drill into that and see exactly when that happened. And now you can say, yes, there was a change. And it was because something happened with the target group for this load balancer.
It was like a DVR. It was like a dish network remote for your cloud monitoring. It was really cool.
Yeah.
Yeah, it's like at the end of the day, a lot of our customers are included or using, Kubernetes stacks within the cloud, and there are multiple pods. And so if you have, let's say, an application become unavailable and you get a 503, that's typically not enough. How can I help you understand why you're seeing a 503? What's happening with the health of those pods within the Kubernetes instance? And so you can actually now go within Cloud Insights views, you can click on the target group itself, and you see a config diff of how things were before and how things are after. And we're pulling this using API. So the drain event that you're talking about is, a pod that's healthy all of a sudden starts draining because of a health event into that application stack. And this is super helpful for a cloud operations engineer and SRE that is trying to understand in real time, how do you act upon an issue that's impacting your customers, and can you take quick actions to reduce the time it takes to resolve those issues?
I remember trying to troubleshoot an issue. This was probably a year and a half ago, and we would have some bursty internet traffic when we were doing uploads. And this is an AWS VPC using a NAT gateway. And when we would see this bursty traffic, a lot of it would drop in these blips as we incremented up. And we thought, that is wild. We had no idea. We looked at logs for like 6 hours, and we found that on the back end, the NAT gateways would scale. They're auto scale groups. So when they reach a threshold, they would bump to another, and there'd be a blip when it transitions to the next one. And I am sure with this tool, it would have been blatantly obvious what was going on. And I wouldn't have had to spend 6 hours reading logs for all the different services that we might have touched, including all our application logs, to find it. I don't have any further comment there. I'm just really sad I didn't have this tool at that time.
Well, if we can go back in time and build it sooner, we would have probably done it. The point, though, that you mentioned was really interesting, is being able to also tie in increase and decrease in traffic and how that's impacting performance. So one of the other things that we're doing with Cloud Insights is we're also filtering VPC flow logs that you let us ingest on your behalf using our SaaS service, and then filter it down to that service and the infrastructure that's supporting that service, and tell you whether that load balancer is seeing a dramatic increase or decrease in traffic and how that's impacting performance. So in one sort of visual view, you're going from the amount of traffic going across that infrastructure, the actual topology of the infrastructure for that service, and changes across that topology and how that's impacting performance, all tied with performance indicators that ThousandEyes already collects from agents.
That's incredible.
Now, when you were showing us the demonstration, one thing that you pointed out was all the different, I think they were listeners, maybe, they all had TF at the end. And I know what I think of when I see TF. And then you confirm my suspicions. So what did the TF stand for?
We treat our monitoring stack as a first-class citizen across how we also deploy services. So our cloud operations team uses Terraform to deploy services across the cloud. And we also deploy ThousandEyes tests and the monitoring of those services using Terraform. So one of the things that we did a few years ago was build a Terraform provider. And we maintain a Terraform provider that essentially provides a translation layer between our APIs and Terraform. And so our developers, our SRE audiences, can actually use Terraform to be able also spin up or spin down ThousandEyes tests as services are spun up and spun down. And that's really key because you want to automate as much as possible across your stack. And it also allows you to maintain a very clean monitoring stack, because one of the things we typically see with folks that maybe are early in their journey automation is you start to get sort of this divergence from what services actually exist and what you're monitoring. And you want to ensure that that's as least as possible, or at least you don't have as much divergence between those two. And so it's something we use, and that's what TF stands for. We use Terraform for almost everything across ThousandEyes.
That's so exciting. Ned and I are both very heavily involved in Terraform, which our listeners know, but we get so visibly excited when someone says Terraform on the call. There's a Terraform provider for this. I literally start jumping up and down in my chair, and you can't see that, so I have to describe it for the listeners.
I know that platform teams are looking for ways to make sure that the best practices are being followed and that everything is automated and that there's a golden path for things. And having a Terraform provider is one of the easiest ways to do that, because you can just integrate it to your existing infrastructure as code. It's not like you have to learn a whole new language and a whole new tool.
Prab was talking earlier that they didn't want to co-locate in AWS where a lot of their clients were, because you didn't want to share any dependencies. And it's the exact same thing here. You require monitoring for your applications too, to be present and to be configured correctly, because if it breaks, if it's not present, then you can't fix your application and you can't deliver value to your clients. You require monitoring to be built correctly. Terraform gets you there.
The last thing I want to ask about, and this came up yesterday because we had a little bit of a gripe session about KQL, is how do I interact with ThousandEyes beyond just the visualization component? If I do need to get into the logs and start searching for things, what sort of interface do you provide for searching those logs or generating additional visualizations?
Yeah, great question. So we built sort of a general purpose VPC flow log analyzer and a backend system. So if you are collecting VPC flow logs and it's in an S3 bucket, you can create an integration where we ingest it as part of our system and allow you to more intelligently investigate traffic flows between services within the cloud, between the cloud and some parts of the internet, between the cloud and an on-premise environment. So we've really built sort of this user-friendly, purpose-built VPC flow log analyzer UI that allows you to not have to become an expert at SQL or these languages that basically would allow you to query VPC flow logs if you didn't have sort of a purpose-built tool. Because most customers that we know within cloud providers, they try to use the homegrown tools or native tools within AWS or other cloud providers. So we know customers that would use, like, for example, AWS Athena, but that requires you to become somewhat of an expert at SQL and how do you query VPC flow logs at scale. And so can we provide you a user-friendly way of visualizing and also seeing historical trends between services? So you can better do network planning. You can also identify dependencies that you didn't know exist. And what we really want to get to overall is providing this as a data source to help you predict changes as you make potential policy changes or config changes. So you can better identify dependencies based on VPC flow logs. And that's something that continues to be kind of our North Star. And how do we actually utilize this data to be able to help our ops engineers that are looking to essentially mitigate any potential downtime to changes that they're making within cloud providers?
I'm seeing that DVR remote going into the future, going a little ways into the future to see what's going to happen if we apply this change. That's like the gold star for network changes, being able to predict what'll happen. That sounds incredible.
Well, Prab and Nelson, this has been a fascinating conversation. And I think Kyler would like you to find a time machine and go back and save for 6 hours.
So much time.
Yeah, barring that, if folks are interested, they want to learn more about ThousandEyes and Cloud Insights, where would you point them?
Yeah, honestly, the best place to get started, just go to thousandeyes.com. There's more information around all of our products there, especially even the newer products that we're building. And you can always sign up for a free trial. You can go to the website, you can kick the tires. And if there's any questions, there's a live chat embedded within the product. So you can ask questions to a real life human. It's not an AI agent that you're talking to that'll answer your questions 24/7, 365.
Amazing. And we'll include links to that in the show notes. As always, Prab and Nelson, it's been an absolute pleasure. Thank you once again for appearing. And hey, dear listeners, virtual high fives to you for tuning in. We appreciate you. If you have suggestions for future shows, we would love to hear about them. You can reach out to me or Kyler on LinkedIn or hit up the feedback link at packetpushers.net/follow-up. Hey, did you know that Packet Pushers has a weekly newsletter? It is loaded with the best stuff that we found on the internet, plus our own feature articles and commentary. It's free and it does not suck. You can get the next issue by going to packetpushers.net/newsletter. Until next time, just remember that DevOps is awesome, and so are you.